Hello and welcome to my YouTube channel. Today I'm going to talk to you about data quality checks. Data quality tools are a scam. For example, we have Great Expectations, Monte Carlo, Sodacor. These tools charge anywhere from 50,000 to 150,000 per year. And for what? Just to run SQL queries basically. And that's it. It's a SQL query that selects rows that fails your check. And today I'm going to show you exactly how to do that yourself in Python with zero third-party dependencies. And by the end of this video, you will have a working data quality framework you can drop into any Python pipeline, and you're good to go. We're going to build the data quality checks from scratch, covering 6 different types of check, and you will actually need, these are the checks you actually need in real life. We check for numeric range, which means if you have 1 to 100, it shouldn't be more than 100, and you shouldn't have a negative value. And we also check for regex pattern. This is debatable, but at least we'll run those checks. Then we'll level things up a bit and look at the threshold based checks. And finally, we'll wrap it all up into a mini data quality report and the kind of things you actually run in production. So we are using DocDB for today as our query engine. It's the only install you need, and it's run entirely in process, no database server setup needed. So before we write a single line of code, let me give you the mental model that unlocks all of this. Every data quality checks, whether it's from a 100K tool or written by you, it follows a simple pattern. So, and that pattern is this: you write a SQL query and it selects the rows which fails your check. If 0 rows come back, then the check pass. If 1 or 2 rows come back or more, then the check fail. And that's it. That's the whole secret. So instead of asking, are these valid row valid, you ask, show me the invalid rows, and if there are none, then you are good. This approach has a massive benefit. When something fails, you already have the offending rows sitting right there for you to debug. Let me show you exactly what this looks like in code. So, but first of all, let's create a realistic data set that we're going to use. Other tables with 10 rows, and I'm deliberately injecting some bad data into it so that we can watch how the checks catches it. But before we start, we'll first set up the sample data set that we're going to use, and I've already created the data set somewhere. We'll just copy those data sets all over so we move faster. So this is the data set, and the data set is the other table. I created the other table here, and I insert 10 columns, and then we have some bad data columns that are already present in these columns. So the last 5 rows are the bad data, and I also want us to do something. Let's create a print statement that prints the database. So the print statement that says, so our demo database is ready with 10 others, including some bad data for testing. Exactly, that works. So this is what we have, and then we're going to look for, as I said earlier, 6 different checks. And our first check is going to be, we check for values, the column values in allowed set. Check for column values in allowed set, and then we can create a function for this, which says check values in set. And if you are checking values in set, what we want to do is to open the bracket up, and then we have the connections, the database connection, and we have the table name, which is going to be in string. We have the column name, which is going to be in string as well, and then we have the allowed values, which is going to be, instead of set, we can use set or we can use list, either of the two. And then we check for So just say it pass if every value in the column name is within allowed values. We put placeholders, which is length of allowed values, but we change this slightly to be equals to something like, once this is joined, then we put front half, then the values, and then values in allow values. That works. And then we write the SQL query to select it. SQL query, which we have now, which will give us all. Let's select all because we have a sample data set. But if you have a large data set, you can specify what you want to select to see. So from the table name, where the column name is not in the placeholders, that's correct. And then we have our column name is null, and then we limit it. So after we close it up, let's specify the rows to be equals to the connection dot the execute. We execute the SQL, and then if we fetch all, once we fetch all, what should we return? Then we return the length of row, which is if it pass if no rows are returned. That's what this specifically means. So this is for the first column. This is what the first check, which is check for values in allowed set. Our next set is to check for no nulls in a column. So, and for this as well, we create a function. That check not nulls. So the next check is the not null, and what the nulls does is, because nulls are sneaky, they slip through the injection pipelines and they break downstream aggregations. So that's why they are surprisingly easy to miss without a dedicated check. So we just use this one line of SQL, but run this on every critical column that you want in your pipeline, and you will catch a huge class of bugs before they even reach your dashboards. So, and if anyone fails, you know where to go to resolve those errors. And we also check for uniqueness. After uniqueness, we check for the numeric range, which you see everything in the code. We also check for regex pattern, like I said before. We check for the thresholds. We check for threshold debugs. So once you check for threshold debugs as well, we then create a full data quality framework report that shows how we're going to do this. So as you can see, we have all the code ready now. No nulls in column. We have the column values are unique, and we have the numeric values within range, which has been set up. And then we have the regex pattern, which we're going to also check for. Then row count within the expected range, which is if you have rows within 1 to 100, select the failing rows and then the sequence count of the number of rows, and then it shows us if it passes or if it fails. So this is all the code you need to create your data quality checks. I created all this run all checks and produce a report. It will print the data quality report, the table name, if they pass or if they pass, how many pass, how many fail, versus the total number of checks that we've set up. So we run everything now and see which one pass and which one fail. So in your terminal, I'll enlarge this. Just run Python 3, no module name, docdb. So let's see, pip 3 install docdb. Let's check the version of docdb that we have. So docdb dash version. We have DocDB installed. Could be the problem. So we have this problem of importing DocDB, and after troubleshooting, so the problem with this is that my Python is externally managed, so I need to create a virtual environment to manage DocDB. And activate. So I'll activate the virtual environment, and from this virtual environment I can run my script to quality demo.py, and that works after we create a virtual environment. So now so after we run all these 6 checks together and see the full report, so the full report give us the data quality report in order. So we have the status values in allow set, give us allowed, complete, pending, shipped and funded. And then we have so that means that fails, this quality check failed. And then we have the status columns that has nulls, which also fails. And we have the order in ID is unique, and it also failed. And we have amount that is greater than 0, no negative orders is also failed. That means we have some negative value. And in our pass email matches basic pattern, we have not an email, which also failed. And then we have the order count between 5 to 10,000, which pass. So we have like 1 out of 6 pass, which means we have 5 fails. So in our report, we have the status values in allow set threshold give us 80% must pass, that passed. Then the pass rate is also 80% that we set up. So the fail count is 2 out of 10 rows, so that means the result is passed. So with pass threshold of 0.880%, which is 80%, only 20% has bad rows in passes. So investigating, we have the duplicate order ID, which is 1001, which appears 2 times, is a duplicate. So, and that's it, folks. That's what you check for data quality. So 5 failures, 1 pass, 1 deliberate bad data got caught by every single check. So this report format is what you will pipe into your login system or your Slack alert or your monitoring dashboard to give you alerts when you run your data pipelines. So in production, you typically run these checks after every pipeline run. So just so that you know something is wrong. So you log the result into your data quality result logs, and then or data quality result table for trending. Then you create an alert for via your PagerDuty or your email address. So then you can then get the downstream pipeline steps in the data quality checks result. So and that's it. 6 production gate data quality checks, no great expectations, no Monte Carlo, no 100,000 vendor invoice to waiting for you. So to recap what we built so far: a reusable SQL-based check system, check pattern system, and then 6 check types: value insert, not null, unique, range, regex, and row count. And then we create a pro mode with pass threshold and a debug samples. And then we created a mini data quality framework with a clean report. The code is linked in the description below, and drop it into your pipeline today. If you want to go deeper, the next video covers write, audit, publish pattern, and how to get your entire pipeline on data quality results before exposing your data to consumers. Subscribe so you don't miss it. If this helps you, smash the like button, subscribe, hit the notification bell, and it will genuinely help this reach more engineers who are tired of paying for overpriced tools. So see you in the next one. Thank you.